Today's webinar. Today, both Siemens and ARC Industry will be presenting in regards to a new solution, optimize capital assets in project delivery and in operations. Today's presentation will take a look at the technologies and the partnership of Siemens and Bentley systems that came together to deliver this solution. We'll talk about specifically Siemens Teamcenter technology, and then we'll talk about specifically Bentley Systems iModel technology. I will present the solution called Teamcenter for CALM, or Capital Asset Lifecycle Management. And then our advisor, our ARC advisor, Dick Slansky, is with us today, and he'll talk about a white paper that he authored around this topic. All right, let's dive right in. First thing that we kind of want to look at is this strategic partnership between Siemens and Bentley Systems. So back in 2016, a partnership or strategic alliance was announced. And some interesting facts about the partnership is that Siemens actually owns about 9% of Bentley Systems through non-voting common stock. And we have a joint, the two companies together have a joint development fund of 100 million euros. Originally it was 50 million euros, was increased to 100 million euros to focus on joint projects like the topic that we're talking about today. In August of 2018, we made an announcement or a press release to the public that we intended to deliver upon a solution that will optimize capital assets in project delivery and operations. And in September of 2019, earlier this month, we delivered this solution to the marketplace. We put out a press release, and we are actively engaged with customers on this solution. Next thing we're going to look at is the technologies that are being used in this solution. One of them is Siemens Teamcenter. So Siemens Teamcenter is actually the most widely used PLM system today. What is PLM? PLM is product lifecycle management. And a PLM system is designed to connect the people, all the stakeholders, and the processes across all the different functional silos through a lifecycle. So when we talk about the asset lifecycle, we think about a design. We think about planning. We think about design and engineering. We think about construction, operations. These are all the different functional silos that have to be connected, right, to take a holistic view of the asset lifecycle. So a PLM system, again, is designed to connect all these people with a common digital thread to increase innovation and to support new business models. And kind of reiterating that on the bottom, what does this mean? Okay, so a PLM system is a data management system, a collaboration system, right, that spans the life cycle of a product, system, or plant. What we'll look at is the positioning of Teamcenter. So this diamond here that you see, this is the representation of Teamcenter, and it has a number of capabilities really centered around business processes, right, that enable an organization to manage all the data through the asset lifecycle. So from the planning stage, you have things like requirements, specifications. You have ways of viewing, the plant, called configuration management. You have ways of, controlling cost. When you move into design, you think about mechanical design, you think about electrical design from equipment perspective. And when you think about an asset, you think about, what's generally known as plant CAD. You think about data coming from these third-party applications into Teamcenter. And when you look at the right side of the diamond, these are all the capabilities that Teamcenter has around visualizing this data, analyzing the data through analytics, right? Providing service and connecting to your suppliers. So we position Teamcenter, as you can see, at the center of this asset lifecycle. On the top part of the circle of the lifecycle, you see capital project phase. This is the planning and designing of a greenfield or brownfield project. And then that moves into a procurement and construction stage. And on the lower half, you see the asset management phase of a life cycle. And this is where you operate and maintain your plant, right? And then you also do modernizations, potentially even decommissioning as plants, shut down. So we see Teamcenter as at the center of this life cycle, managing the evolution of the data from planning all the way to decommissioning. The next thing we're going to look at is the Bentley I model. Again, Bentley Systems and Siemens have come together to create this solution using these technologies. So what exactly is an I model? I model is essentially information exchange. So where it's used today, it's used to exchange information for projects associated to the life cycle of capital assets. So what does all this mean? Essentially, we're able to take the data from the leading plant design and engineering tools that you see today in the marketplace, that information through the I model, through this Bentley technology, and into Teamcenter, right, where they become first-class objects. So they're not just files that we're sharing and we hold a named file within our system. They actually become digitalized, right? And that means it becomes an object within our system. So with an iModel, iModels ensure that that information will flow easily, completely, and accurately the entire life cycle, design, construction, operations. It shares all the component information, including business properties, geometry, graphics, and relationships in a format that is open. So this is, honestly a really big deal. The iModel technology enables us to bring in that has been traditionally trapped or siloed in the design and engineering authoring tools that the market uses today. Next slide. So let's start talking a little bit about the solution. So Siemens and Bentley have delivered this solution to the energy and utility market. See, the scope increasing into other markets, but our primary target was energy and utilities. And again, we combine that Bentley I model with that Siemens Teamcenter technology to do what? To dynamically manage complex capital projects. Right? And then further to optimize the performance of operational assets. And ultimately what you get at the end when you're able to properly manage this data, consolidate it, manage it, trace it, you're able to deliver a digital twin of a plant. A digital twin to visualize everything within that plant. And more importantly, I believe it allows you to simulate. So when you think about the life cycle of a plant, you think about it's in a project, it moves into operations, and then when you need to, of course you need to improve performance and efficiency. You need to take all the information that you have today that came from that project, bring it back into design and engineering, right? And simulate to improve operational efficiencies. So it's connected. You can't think about a project on the left side and operations on the right. It has to be connected in order to achieve new efficiencies that are required today, especially in the energy and utilities industry. Some of the trends and challenges that are pushing this connection or this lifecycle management of plant data are on the left. Really high levels of market volatility. You see these depressed prices in oil. The stakeholders that come together to build these projects, whether it's, again, greenfield or brownfield, they're very document centric. What does that mean? That means that when the project is finished and when the system is built, when the plant is built, the owners and the operators that are operating that plant, they don't have digitized data. They have files and they have PDFs that are printed off, right? And that's the power of Teamcenter. We're able to take all that data that's traditionally document centric and convert it and digitalize it into objects that can now be reused in the context of simulation, in the context of integrated planning, and and things like digital handover are enabled. We're able to use our Mendix application, rapid application development solution to build apps that take bite-sized chunks of data, right? So your people in the construction or operations can have an app where they can quickly assess the information that they need. So these are some of the trends on the left that are affecting industry, and Siemens has a vision on how digitalization will disrupt this industry, right, and change it for the better. All right, so let's dive right in. Let's look at this presentation. Let's identify, okay, these problems, and then let's see what the solution is. with this Team Center for Capital Asset Lifecycle Management. First thing we want to look at are capital projects. So we talked about that, either greenfield or brownfield. Across the board, they perform very poorly. 98% of these mega projects incur cost overruns and delays. 80% is average cost increase. 20 months, that's almost 2 years average slippage behind schedule. The construction industry, which is a cornerstone of capital projects, is number 21 out of 22 industries studied for a digitization index. 22 is agriculture and hunting. So that really lets you know that, again, about that document-centric nature of this business. When we compare manufacturing to construction, over the last 20 years, the labor productivity rate, or difference, as I say, is 52%. That's how, that's an outstanding amount of productivity lost, right, over that amount of time period. And we feel with PLM concepts, PLM processes, the productivity gap can be decreased, right? And construction can catch up to manufacturing. Some of the trends that you see in these projects are increased global competition. So you have firms that are getting a lot of experience in developing nations. They're competing globally now, right? As they've developed a specific skill set and expertise. You see the increased project size and complexity. You think about lump sum turnkey contracts, pushes all the onus on, or all the responsibility, if you will, back onto the contractors. The contractors need to perform. You need to digitalize and need to find ways to increase operational efficiencies when they deliver the plant or system. We also see an increased rate of technology. So there's a lot of people in the marketplace, vendors, if you will, that are bringing solutions to market, and that in turn makes it a little harder, if you will, for owner operators and EPCs to to understand what's available to them. And lastly, decreased labor force as the median age of the stakeholders that are involved in this business increase. More people retire, and less people come to fill their shoes, and so that's a real problem in the industry. At Siemens, we believe digitalization changes everything. There's a difference between digitization, and digitalization. Digitization is taking a document and scanning it, right, and converting it into a PDF. That doesn't provide any inherent business value. Digitalization takes that information, that PDF, and converts it, right, into, in this situation, into objects where it can be reused, right, throughout the life cycle. So digitalization changes everything. And we apply digitalization to capital projects. So what do we know about capital projects? Capital projects require thousands of great decisions, and digitalization can help us do that. We know that more people are collaborating. We know more people are searching for information. We're making complex decisions, and they're under pressure with less room for error. That's the landscape today. So with digitalization and with this solution, Siemens Team Center and Bentley Systems have come together to deliver. What makes a good project decision? The right information at the right time in the right context, right the first time. And that's the core of Team Center. That's the core of this data management capabilities, is to deliver that information to the right user in the right context, right the first time. Let's look at the three key deliverables that this solution brings. One is the ability to realize continuous optimization, and that is through a digital twin. Digital twin keeps a virtual representation of your actual plant as operated, right? Moving into as operated, moving into as maintained. That's a digital twin. All right. Next thing we can deliver is help you manage your project complexity, and lastly, help you make smarter collaborative decisions. We're going to walk through these three topics today. So first, we'll look at the digital twin. So this visual here, we look at this visual from left to right. And on the left, we see a process digital twin circle. What is that? So it's a virtual process design and engineering. So all the design and engineering that happens from conceptual design to front end engineering, detailed design happens inside this twin. That means we're virtually simulating and capturing all this information, optimizing it to the best of its ability. That data then moves into the plant digital twin. Plant digital twin is where we can visualize, simulate, and predict and plan construction execution. Okay, so that way, you're able to simulate all these activities coming together and ensure efficient constructability. That way, when it comes time to really build the plant, as you see in the blue bubble, real plant build, you've already went through the scenarios, you've already simulated them, and you are reducing the amount of errors that can occur. Again, this data from design and engineering, moving into the construction phase, right? And then on the far right, you see a performance digital twin. This is after commissioning has happened. Now you have an operational plant or asset, okay? And this is all about these insights from performance, what we call IoT, and Siemens has a really great platform called MindSphere to help you do this. So you take the operational asset, you monitor its performance, and that feeds all the way back to the left side of the screen to your virtual process design, right? Where you can, again, take the performance of that, let's say, pump or that system, right? And you can manipulate it and simulate it to what? To increase operational efficiencies. So that is continuous improvement. It's a closed loop kind of mechanism. The information continually cycles left to right, left to right, left to right. That is what we call capital asset digital twin. One thing I do want to add on the performance side, on the right side of the visual, right? Teamcenter has what we call so on the right side, how do you, after you commission system or a plant and it's operational, how do you keep the digital twin up to date? We have enterprise integrations into maintenance systems like IBM Maximo that will help you do that. That way, as you switch out that pump in operations, all that data is then reflected in Teamcenter as the central repository, right? That is continually evergreen and refreshed with the changes that are happening in operations. Next thing we want to look at is enterprise insight. So one of the things I think we talked about earlier was these silos of data, right? Our stakeholders in this industry, their designs are in one system, their documents are in another, their suppliers are managed in a different system, their processes aren't connected. So everything is scattered all around, right? And people are accessing the information in different ways. There's no way to reuse it, assess it. And so with Teamcenter, what we're able to provide is the right information at the right time, context, right the first time. So everyone is accessing the data in a single point, right? And that way, this data can, again, be reused. You can apply all kinds of things. You can connect to your internal and external stakeholders. Everyone is accessing the information, right, in a single system. And a single point of access, or this enterprise insight, give you ability to apply visualization and analytics. So we can visualize all this plant data in 3D, in 2D, 1D. We can cross-probe it. We can get our program performance. We can see measurements of key metrics throughout the program or project. Side of the screen on this slide, you can see what I'm talking about when I say you can visualize plant data. On the left side, this picture, there's a 1D structure, which is like a BOM, a bill of material listing. These are all the plant objects. On the top, you can see a 3D model. So this is actually, visually the plant and how it'll look. And on the bottom, you can see a 2D, what's called a P&ID drawing. And so these are all connected. When you select an object in any of these views, it will appear in the other views, right? So if you click on the 1D structure, you'll see it in 2D and 3D. Very cool feature about this solution. When we look on the right side of the screen, here's an example of our visualization and analytics capabilities when applied to events. So you can see the event is a commissioning, and you can see there's critical work packages that are still open. There's open change requests. And people across the enterprise can assess the status of this event or this project. And people from the C-level to program managers, everyone across the organization has that understanding into what's happening. Thing is true here. Here's a dashboard of a pump design, right? And there's open change requests and critical issues going on, and program managers can quickly assess, okay, what needs done, where are we at, basis the schedule, and how can I help my employees, right, get the job done faster. Here's another example of a burn down chart. So again, maybe more of a C-level visualization to see, okay, wow, things are really coming to a head here. We are getting close to completing this project. Next, let's look at what we're calling program management. So when we think about program management in this context, we're talking about the integration of engineering and construction, right? We're looking to accelerate your planning, ensure accuracy, increase compliance and safety. Ultimately, what we're able to do is we're able to bring together your when, how, and what, right? So the program plan, your work breakdown, and the plant breakdown. We're able to bring all three of those together in a single system to help you understand the real-time status of project execution. Can complement your legacy investments. Like I mentioned earlier about enterprise integrations, of integrations with Primavera and NMS project. So this is a visual of what I just explained. On the left side is the program plan, the when, the middle is work breakdown how, and the right is the plant breakdown what. And they're all connected. The event is connected to the work package, and the work package is connected to the system. Everything's connected, and that's how you're able to get real data analytics, understanding of how the project is performing. One of the core features and proven aspects of Teamcenter are its business process capabilities. And change management is one of those business processes where we really excel. So many people in this industry don't have a digital traceable change process, right? Across organizations, across your organization and across, your contractor's organization. So we can help facilitate that with our change management process. Again, all digital, all traceable, feeding into these dashboards so you can fully understand the impact of change, schedule, and cost. Another business process that we like to talk about, I think we really excel at, is requirements management, right? Requirement specifications are associated to, let's say, the design of a system or a pump, a piece of equipment, I should say. And with our requirements tied to these objects and tied to the design, you can help increase design compliance, reduce time, right? Enable traceability. Well, how is this pump designed and why, and all those good things. Requirements management is actually tied to the, the objects, right, that are in the plant and that are inside Teamcenter. Here's an example of that. On the left, we've clicked an element or an object in the plant, and we trace link that to a requirement spec. And then we're able to click on that requirement spec, and it simply opens up. You can read all about that specification and why the design was the way it was, and if the design meets the requirement spec. Another one I wanted to highlight, another business process, was configuration management. So one of the big things in this industry is understanding how project unfolds. You do that through visualization of project milestones. That project may be 30% complete. That project may be 60% complete. And you're kind of just saying, what data makes up 30%? How long do you have to guess? Now we can capture all the data as objects, right? And associate that to milestones. So you're able to actually visually see all the details that make up 30%, all the design and engineering information, let's say, right, at 30%, and compare that to a work in progress, or compare that to, let's say, 60%. And what does that look like inside our solution? So on the left, you can see example of, let's say, 30% on the left, and on the right is example of 60%. And what you can see is that which objects in these two data sets have been added, modified, or deleted, right? And so now you have more of a data-centric approach to understanding milestones and understanding what has changed between those two milestones. That brings me to the end of the sales, or if you will, the presentation. And really, we feel we can help customers achieve, or accelerate their project delivery. We feel like we can help them reduce cost and waste, ensure safety and quality, realize a higher profitability, and achieve best-in-class success. So these are kind of like some of the value points that we feel like we can bring out. To introduce from our ARC advisory group, Dick Slansky, again, and he is authored a white paper on this topic, and he'd like to share with you some of his thoughts on that white paper and this solution.
Thank you, Justin, for that introduction, and thank you to all those out there attending this webinar today. As a senior analyst at ARC Advisory Group, my responsibilities include conducting market research in the engineering design tools sector, engineering design tools for both plant design and infrastructure and those suppliers in that space. I also conduct market research in the area of PLM and in the area of the overall Internet of Things, the industrial Internet of Things, and that in production systems and companies that are moving towards this area in digital transformation. What we're really talking about here is the digital twin for the intelligent plant. Siemens and Bentley are delivering these energy and utility solutions together in this within this partnership. And what this enables the users to do is to dynamically manage the complex capital projects and preserve the existing assets that are part of these projects on the operations side. The basic concept here is to remove the boundaries between the plant and the enterprise data. So what we're doing here with this partnership is bringing together two best of breed solution sets with Siemens Teamcenter portfolio of their enterprise data management, and of course the Bentley Systems iModel service, or the iModel Hub service. The idea is to offer an integrated solution that to digitalize and optimize this life cycle. This what we call the OpEx, the CapEx to OpEx life cycle. It's clearly a value add by combining Teamcenter enterprise data management with the Bentley iModel Hub to digitize or provide the digitalization of this entire CapEx to OpEx lifecycle. In other words, connecting those areas, the CapEx side, which is traditionally the design build or design construct part of the lifecycle, with the operations or the side of the which is, occurs after the handover when the owner operators take over the facility. But what we really need to do here, and this addresses a traditionally an area that has been traditionally challenged, to offer a continuous and consistent data thread from the capital project itself to the plant operations. So what we're doing is applying this notion of the digital twin, which we're connecting the virtual and the physical worlds. In other words, the engineering design, the virtual world of engineering design, and the models, and all of those virtual tools and applications with the actual physical aspect of the plant and the plant operations. So Teamcenter represents the data management aspect of this for the capital asset management. Currently, Teamcenter, from the market perspective, is definitely the market leader for for product data management in the PLM, within the PLM market. This has been established for many years. They are the dominant presence in this PLM market. Now, as we move over into the the plant design space and capital project space, we're taking all of the strong points and aspects that Teamcenter PDM solutions have traditionally provided, and applying them to this area of capital projects. for plant design and for the capital asset, the asset management aspects. Team Center functions basically in a typical project today for plant design or infrastructure as the single point of access for all the federated data, including all the related data, engineering, design, the procurement, materials management, so forth, the equipment and assets, and then and of course the construction processes, and then the overall project management. The Team Center has its strong point has traditionally been as a functioning as an enterprise repository for all the plant breakdown data. It provides a visualization platform for all the 2D, 3D models across all of the projects. One way that the users can access this is through Team Center's web-based client platform called Active Workspace, which allows the stakeholders across this life cycle, across this CapEx to OpEx life cycle, and across this entire design, build, maintain, and operate life cycle to collaborate and to have access to all of the data stored in this enterprise repository. In other words, it's taking that notion, that concept of a single source of the truth, if you will, that has been so critical to the discrete industries over the years, and what Team Center has brought to that sector is applying it now into this CapEx to OpEx life cycle for plant design and construction and operation and maintain. Then moving over to the other side of the coin, and the other side of the partnership is Bentley's iModels. Now, a typical project today, a typical capital project out there would involve quite a disparate range of stakeholders. You have a project design team who are using the engineering design tools afforded to them by the suppliers such as Bentley. And then also you have to have communication with and coordination and collaboration with multiple subcontractors, procurement and materials suppliers, and of course the construction companies themselves, the prime contractor involved at all the various stages of the construction schedule. I might add here that, as Justin alluded to earlier, one of the areas that it causes the most issues in capital projects today is making that transition from the design aspect, the design side, which really only accounts for maybe 4 to 5% at most of the actual cost of the project. When you move to the procurement stage, materials management stage, and ultimately to the construction stage, that's when you start to incur the real cost of the project. And that is where delays and inconsistencies and lack of availability to engineering, to the latest updates and to the latest changes and so forth across that engineering activity, and have the latest change management available. This is what really causes the most problems, because you have this really disparate group of contractors and subcontractors and material suppliers and so forth. This is where this combination of Bentley's iModels and of the Team Center platform really comes in to significantly improve this process. So basically users can share all of the component information, including all the business properties, but they can also share the models themselves, the engineering models themselves, the geometry and the graphics, and it also provides them of the opportunity to be in a very interoperable um, environment. Interoperability is essential, because the most typical capital project, and when you consider all of the contractors and subcontractors involved, you could have a variety of design tools with different formats and there has to be an interoperability between this. That has existed, and in this design world for many years. But having a Teamcenter platform enhances this interoperability significantly. This Siemens Teamcenter Bentley iModels partnership really offers a unique value proposition, and I'm saying this from the perspective of an industry analyst looking at this from a third party perspective. I might point out here that Siemens and Bentley have been partnering with for many years, actually, with their respective technologies. We've seen a partnership between the Siemens Comos application, which is basically a 2D application for plant layout and P&ID for process plants. They've teamed up with the Bentley's Open Plant, which offers the users a 3D environment, a 3D plant design environment. And then, so you're combining this 3D graphics, 3D models environment of Open Plant, excuse me, with the object database capabilities of Comos, and you have a very strong solution for plant design. Siemens PLM has also partnered with Bentley with their Technomatics factory simulation. This is 3D factory simulation of a discrete manufacturing plant or factory with all of those processes that would be used in manufacturing or production environment, such as robotics workstations and production assembly and so forth. And they've combined that with the NX Line Designer with Bentley's laser point cloud modeling solution, which the users then can use to actually use laser point cloud technology to capture the existing infrastructure, the existing building and facility that exists, and then combine the two systems together, the production system simulation with the building, the actual building, brick and mortar, if you will, that houses the production line, so that they can work out all types of compatibility and obstruction and issues and so forth. And then more recently, I think around 2018, the two companies have joined together to offer PlantSight, which is a cloud-based solutions that offers an actual virtual representation. It's a sort of an as-operated and up-to-date that can update the digital twin and synchronize them in real time. So it brings together both the physical environment and the virtual environment in a holistic digital context for that the users can use. At ARC, we have developed strategies over a period of time on a more generic level to address this notion or this issue of the importance of engineering information that is essential to plant operations and how it needs to be provided to the OPEX side of this life cycle. So we have a concept called Asset Lifecycle Information Management, ALIM, which defines this continuous flow of the design build information between both the CapEx and the OpEx life cycles. In other words, it provides a continuous flow of the system. A system should be able to provide a continuous flow of engineering information and project information to the operations side. Historically, when a capital project took place, the CapEx side was run by the EPC, the construction company, and the engineering design, the engineering company that actually designed the plant and then constructed it. And then there was a distinct event called the handover. And this was a one-time event where once the CapEx side of the project was completed, in other words, the design build was completed, then the EPC handed over to the operations folks this engineering information, construction information, and basically all of the functional information, both from a design and construct aspect, to the operation, to the owner operators, the operating of the facility. What we've seen evolve in this area is that one time just single event of handover has evolved into more of this continuum of information that has to be continuously moved across this life cycle. So as you move from the project managers and the design engineers and the fabricators and the constructors and so forth, this information should be readily available to the operations to the operations side of the house. In other words, to the owner operators, and it should continue to be provided across this. So basically, it's a continuous it's a repository for a continuum or a continuous collaboration and access of information across this entire design, construct, maintain life cycle. And what we really have here with this the partnership between Siemens Teamcenter and the Bentley Systems iModel Hub is a very, very good manifestation of this entire concept of ALIM. So basically what we really want to do at the end of the day is remove all the boundaries between plant and enterprise data. Teamcenter's strength has traditionally been its enterprise level business and process capabilities. The traditional strength of Bentley's iModel Hub has been this continuous coordination and availability of the engineering models, of information around the construction phase, and basically an exchange of project information. So it's quite evident that a successful capital project has to be able to connect plant data with an enterprise data management system. In the beginning, back in the day, if you will, excuse me, this ability to connect this type of information as at an enterprise data within the context of an enterprise data management system just did not exist for the capital projects. What the Teamcenter and iModel partnership does is establish this connection and enables this continuous digital handover of project data. Another way to look at this is the ability to for the operations side of the house to optimize the performance of the capital assets once they get delivered. And I look at this at three different levels. At the plant data management level, of course, as I mentioned earlier, interoperability is essential, and it's generally supported in the environment today by the plant with the plant engineering design models that can be used by other participants. And as I mentioned, in a typical project, as you go out from the prime contractor throughout all the subcontractors, you're going to find a complete range of design applications. And these could include very specific suppliers: Open Plant from Bentley, Comus from Siemens, Aviva, Hexagon Power Process, and Marine Rivet from Autodesk, and others. There has to be an interoperability between all these systems for them to function at a plant data management level. At the program level, Teamcenter then integrates the engineering and construction with program planning, and not only with program planning and project management, which is essential to manage the overall program plan and the project itself in the project work breakdown. And then at the operational level, this is where Siemens really delivers a very valuable and significant aspect of this overall um, combining of the two areas, and that is in the area of a closed loop digital twin, which is what Justin was talking about earlier. But this is significant as we move into this entire area of where companies are making their digital transformations. A closed loop digital twin will be the key to running these projects in a way that the EPC that is running the project can constantly evaluate and validate what the state of the construction is, and then bounce that off of the actual engineering, the virtual engineering design. So we have the digital twin for the connected intelligent plant, and this is what we're really aiming for here. Is the basic premise of a digital twin is the merging and connection between the virtual engineering, the digital models, and the physical plant equipment and other assets. This is the essence of a digital twin. For industrial plants, the fundamental requirement for digital twin is that the assets must be connected to intelligence. All of those those pieces of equipment and components out there, and say a refinery, for example, all the pumps and the valves and the equipment and the turbines and all of the various pieces of equipment out there have to be connected in this ecosystem, in this closed loop digital twin system, to achieve this efficiency and optimization that the operations people are looking for. So basically we're combining the enterprise data management capabilities of Siemens Teamcenter with the data acquisition and exchange capabilities of the iModel Hub, which really is an ideal environment to implement this closed loop digital twin. So to kind of conclude this here, from a from a market perspective, looking at this as the market for engineering design tools for plant design and infrastructure, the value proposition or what's going on here is a very strong value proposition. Both companies are bringing decades of experience and expertise to the table here, not just in the capital project delivery, but across multiple areas of engineering design, digital modeling, asset management, and overall data management. So I think going forward into the future, each company exhibits their own particular vision for the future of this plant design, architecture, engineering, and construction, and building information management area. And as we move forward in the future, this is going to be applied to a much broader scope, including smart cities and overall infrastructure. So this partnership of systems and platforms, engineering design, construction methods, it's sort of predicated on a democratization of data across all of the areas of the overall life cycle. It has to involve all the players, all the stakeholders in the process. So that concludes my my presentation. Justin, you want to jump in here and add a bit more information for us in conclusion?
Hi, Dick. Yes, thank you. I just want to jump in here and thank everyone for attending today. Thank Dick Slansky from ARC Advisory for joining and for obviously for writing this white paper around the topic. And I wanted to provide some more information. So you can visit us at our website, www.sw.siemens.com. You can also email me as the presenter. My name is Justin. My email is justin.denunzio@siemens.com. And this concludes today's session. Thank you for attending.